Download this code from codegive.com, link in the description below. Debugging failed to read namespaced pod in Kubernetes. The failed to read namespaced pod error in Kubernetes signifies that your application or script is encountering issues when trying to retrieve information about a specific pod within a particular namespace. This error can stem from various root causes, including authentication problems, authorization failures, rbac, network connectivity glitches, or even a deleted pod. This comprehensive guide will walk you through the common causes, troubleshooting steps, and potential solutions to resolve this issue. Understanding the error message asterisk. The error message itself usually looks something like this. Or, breaking it down. Asterisk error from server, indicates the Kubernetes API server itself is returning the error. Asterisk forbidden, this means your application/service account doesn't have the necessary permissions to perform the get operation, read, on pods within the specified namespace. This is usually an rbac, role-based access control, issue. Asterisk not found, the requested pod doesn't exist in the namespace. It might have been deleted or the name is misspelled. Asterisk pods my pod is forbidden, clearly states that the action of getting, reading, the pod named mypod is denied. Asterisk user system service account my namespace my service account, identifies the entity, typically a service account, making the request. Asterisk cannot get resource pods in namespace my namespace, pinpoints the specific resource, pods, the action, get, and the namespace where the error is occurring. Common causes and troubleshooting steps asterisk. Let's explore the most frequent reasons behind this error and how to diagnose them. 1. RBAC, role-based access control, issues, forbidden errors. This is by far the most common culprit. Kubernetes uses RBAC to control access to its resources. Your application, usually running as a service account, needs explicitly granted permissions to interact with pods in the namespace. Asterisk identifying the service account asterisk. First, determine which service account your pod is using. There are several ways to do this. Asterisk check the pod's definition, YAML. Look for the service account name field in the pod's specification. Asterisk inspect the pod's environment variables asterisk. When a pod is created, Kubernetes automatically injects environment variables related to the service account. Look for variables like Kubernetes_service_account_token and Kubernetes_service_host. While these don't directly reveal the name, their presence indicates that the pod is using a service account. Then you can execute into the pod and run cat/var/run/secrets/kubernetes.io/service account/namespace to get the pod's namespace. Combine this with kubectl get pod myapp-pod OYAML and look for service account name. Asterisk check the pod's metadata asterisk. Use kubectl to inspect the pod. Asterisk checking existing roles and role bindings asterisk. Once you know the service account, examine the roles and role bindings associated with it in the target namespace. Asterisk list role bindings in the namespace asterisk. This will show you the bindings that grant permissions to different subjects, users, groups, service accounts, within the My Namespace namespace. Look for bindings that include your service account, system service account My Namespace My Service account. Asterisk list roles in the namespace asterisk. This lists the roles themselves. A role defines a set of permissions, such as the ability to get, list, watch, create, update, or delete resources like pods. Asterisk describe the role binding asterisk. Replace role binding _ name with the name of the role binding you identified earlier. This will show you which role the binding applies and the subjects, service accounts, users, etc. it grants permissions to. Asterisk describe the role asterisk. Replace role underscore name with the name of the role associated with the role binding. This will reveal the specific permissions the role grants, example get pods, list pods, update deployments. Asterisk remediation, creating or modifying roles and role bindings asterisk. If the service account lacks the necessary permissions, you need to create or modify roles and role bindings to grant it access. Here's how to create a role and role binding that allows the service account myServiceAccount in namespace myNamespace to get and list pods. 1. Create a role, example, podReaderRole.yaml. This YAML defines a role named podReaderRole in the myNamespace namespace. It grants the get and list verbs, permissions, on pods. The API groups field is important. For core resources like pods, it's an empty string. 2. Create a role binding, example, podReaderRoleBinding.yaml. This YAML defines a role binding named podReaderRoleBinding in the myNamespace namespace. It binds the podReader role to the service account myServiceAccount in the myNamespace namespace. 3. Apply the role and role binding asterisk. Explanation of the YAML asterisk. Asterisk API version, rbac.authorization.k8s.io/v1, specifies the rbac API version. Asterisk kind, role or kind, role binding, defines the type of resource. Asterisk metadata.name, the name of the role or role binding. Asterisk metadata.namespace, the namespace where the role or role binding is created. Important, this should match the namespace where your pod and service account are located. Asterisk rules, for role defines the permissions. Asterisk API groups, the API group of the resource. For core resources like pods, it's an empty string. Asterisk resources, the resource type, example pods, deployments, services. Asterisk verbs, the actions allowed on the resource, example get, list, create, update, delete, watch. Asterisk subjects, for role binding specifies the entities being granted permissions. Asterisk kind, service account, indicates that the subject is a service account. Other possibilities are user or group. Asterisk name, the name of the service account. Asterisk namespace, the namespace of the service account. Asterisk role ref, for role binding references the role being bound. Asterisk kind, role, the kind of resource being referenced. Asterisk name, the name of the role. Asterisk API group, the API group of the role. Important considerations for RBAC asterisk. Asterisk least privilege asterisk grant only the necessary permissions. Avoid overly broad roles that grant more access than required. Asterisk cluster roles and cluster role bindings asterisk these grant permissions cluster-wide. Use them sparingly and only when necessary for resources that are not namespace specific. Asterisk aggregation asterisk Kubernetes allows aggregating multiple roles into a single role, reducing the number of role bindings needed. 2. Pod doesn't exist, not found errors. The not found error is straightforward but can be caused by simple mistakes. Asterisk verify the pod name asterisk double check that you've typed the pod name correctly. Pod names are case sensitive. Asterisk verify the namespace asterisk ensure you're looking in the correct namespace. Use the namespace flag with kubectl commands, example kubectl get pod myapp pod mynamespace. Asterisk pod has been deleted asterisk the pod might have been deleted due to a deployment update, scaling operation, or manual deletion. Check the events related to the pod. Look for events indicating deletion. Also, check the logs of the pod's controllers, example deployment controller, replica set controller, for events that might have triggered the deletion. Asterisk pod pending / failed asterisk if the pod is in a pending or failed state, it may not be fully created or may have encountered errors during creation. Kubectl describe pod is helpful here as well. Examine the pod's logs and events for clues. 3. Network connectivity issues ***. Less common, but still possible, are networking problems that prevent your application from reaching the Kubernetes API server. *DNS resolution * verify that your pod can resolve the Kubernetes API server's host name. You can try lookup kubernetes.default.svc.cluster.local, or the correct host name for your cluster. Firewall rules check if any firewall rules are blocking traffic between your pod and the API server. This is particularly relevant in environments with strict network security policies. Service network issues problems with the Kubernetes service network, example incorrect CNI configuration, can disrupt communication between pods and the API server. Examine your cluster's networking configuration. 4. Authentication problems ***. Although often related to rbac, authentication issues can also manifest independently. Expired tokens if your application uses a service account token for authentication, ensure that the token is still valid. Tokens can have expiration times, especially in managed Kubernetes environments. Incorrect credentials if you're using a different authentication method, example client certificates, verify that the credentials are correct and properly configured. API server unreachable while network connectivity is usually the culprit, the API server itself might be down or temporarily unavailable. Check the health of your Kubernetes control plane. 5. Code examples, Python and Go. Here are code examples showing how to read a namespaced pod using the Kubernetes client libraries in Python and Go, along with error handling. Python, using Kubernetes library. Go, using client Go. Key takeaways from the code examples error handling the code demonstrates how to handle API exception, Python, and metof1.stat user Go, to catch specific errors like forbidden, 403, and not found, 404. This is crucial for providing informative error messages and graceful error recovery. Kubernetes configuration the code shows how to load the Kubernetes configuration, either from a kubeconfig file or using the in-cluster configuration, when running inside a Kubernetes pod. Client creation the code illustrates how to create a Kubernetes client using the loaded configuration. Namespace and pod name these values are typically passed as arguments or read from environment variables to make the code reusable. Debugging checklist Before diving into code, run through this checklist. 1. Pod and namespace spelling are the pod name and namespace correct? 2. Pod existence does the pod actually exist? Kubectl get pod name and namespace. 3. RBAC permissions does the service account used by your application have the necessary get and list permissions on pods in the target namespace? Check roles and role bindings. 4. Network connectivity can your application's pod reach the Kubernetes API server? Try lookup and check firewall rules. 5. Authentication is the service account token valid? Are credentials correctly configured if you're using a different authentication method? 6. Kubernetes API server health is the API server running and healthy? By systematically investigating these areas, you should be able to pinpoint the cause of the failed to read namespaced pod error and implement the appropriate solution. Remember to prioritize rbac issues, as they are the most frequent source of this problem.